So the book uses the word sums of radicals, but what it really is, and what I wish it was titled, was combining radicals, okay? And so that could be either adding or subtracting. Even though it says sums, it should maybe just say sums and differences. But in order to combine your radicals, you need to have two things. You need to have the same index. Index is just fancy for the root. So if they're both square roots, great. If they're both cubes, great. But if you have a cube root and a square root, they can't combine. And you need to have the same number under the radical. Okay? So when you see a problem like example number 1, we're going to take the square root of 8 plus the square root of 98. And when you first look at it, you might think, okay, yeah, they're both the same index. They're the same root because they're both square roots. But you might think, oh, but they don't have the same number under the radical. Okay? But you do need to simplify first. Okay? So if you can ever simplify, then they will possibly have the same root. They will highly likely have the same root. Okay? So let's look at the square root of 8 first. How can I write, or is there a perfect square factor of 8? 4. So I'm going to rewrite this as the square root of 4 times the square root of, whoops, I started to write 4 again, 2. That's a 2, not a 4. Square root of 4 times the square root of 2. All right, that one's kind of easy to spot, but how about numbers like 98, okay? May not be as recognizable to you, so you'll need to do kind of what we did yesterday. You'll have to start with 98 and do the prime factorization if you're not sure what it is, right? So 2 goes into 98 49 times, and 49 is 7 times 7. So when you rewrite this, you would rewrite it as the square root of 49 times the square root of 2. And then when we simplify it, you're going to be able to see if you are going to be able to combine them. So the square root of 4 is 2, so you have 2 rad 2 for the first term, plus the square root of 49, which is 7, so 7 rad 2. And even though when you first looked at them, you thought, oh, they're not the same number under that radical, now they are. We have square root of 2 and square root of 2. Okay? So you're just going to do what the sign says. In this case, it says add. It could just as easily as subtract, and you combine. So you just combine the two coefficients. 2 plus 7 is 9. So it's 9 rad 2. Right? Any questions on example number 1? All right. That one was a second root. Let's try one with a third root. So example number 2. We're going to do a cube root. So we're going to take the cube root of 81 minus the cube root of 24. So again, we look at them, we say, oh, cool, we have the same index. They're both a 3, but we don't have the same number underneath the symbol, right? So at first, looks like you can't combine them. But we need to simplify, okay? So, do I need to do the prime factorization of 81? So how can I rewrite 81 to a power? 9 squared, right? But if it's only squared, can I take a cube root out of that? No. So how else could I write 81 to a power? What's the square root of 9? 3. So I can say this is the cube root of 3 to the 4th power. We need to take 3 of those apart from one of those, right? How about, how can I rewrite the 24 as a power? This one's a little bit trickier. So let's do the prime factorization of 24. 2 goes in there 12 times, right? 2 goes into 12 6 times, and 2 goes into 6 3 times. So we have a 2 to the third power, and we have a 3 to the first power. Everybody with me so far? Okay. So I'm going to show the step where I separate this. It's a step that you may or may not need to show on your assignment, right? I'm going to rewrite this as the cube root of 3 to the third times the cube root of 3 to the first. You may or may not need to show that, right? And then this one, I'm going to separate as the cube root of 2 to the third times the cube root of 3. All right, so let's see what this simplifies. Cube root of 3 to the third is just 3. So we have 3 cube root of 3 minus, then the cube root of 2 to the third is 2, bless you, cube root of 3. Now our index matched from the beginning, but the number underneath our sign matches, okay? So now they're like terms, right? So now we can just add or subtract the coefficients. This one says to subtract, so it's just going to be 1 cube roots of 3, and you don't even need to write that 1 out there, right? You can just say the cube root of 3. If you want to write the 1 out there, go for it. All right, any questions on example number 2? All right, I have one more. You guys still, okay. Example number 3. And this one's just one of the trickier ones because it has a denominator. Okay, they're all square roots, so the index is good so far, but we definitely don't have the same things that we can add or subtract, right? And we also have the problem right here of we have this radical in the denominator, okay? So how do we get rid of the radical in the denominator? So we have to multiply by the square root of 2 over the square root of 2. So let's rewrite this here. We're going to just rewrite the first term as the square root of 6y. And then this second term, we're going to multiply the square root of 3y times the square root of 2, which is the square root of 6y. And then for the denominator, we're going to multiply the square root of 2 times the square root of 2, which is the square root of 4. What's the square root of 4? 2. Okay? Now, in order to add these, we need to have common denominators. So we start with a denominator of 1, but to get to a denominator of 2, we need to multiply by 2 over 2. Bless you. So that's going to make our first term 2 square root of 6y over 2 minus square root of 6y over 2. Now we have the same index and we have the same thing underneath that radical, right? So we can just subtract. 2 square roots of 6y minus 1 square roots of 6y is just the square root of 6y over 2. And that's a lot more simplified than what we started with. All right?